Welcome to Bamaina math class. In this video, we are going to find the derivative of cos x using first principle method. The question says if y equals to cos x, find dy over dx using first principle method. So finding dy over dx, it means to find the derivative. So we all know that when you differentiate cos x, it will give you minus sine x. So we are going to prove that using first principle method. First of all, we said solution. Now from there, we rewrite the equation given. We have y equals to cos x. So now if you can recall our previous videos, we said that when you are applying first principle method, wherever you see y, you add dy, and wherever you see x, definitely you add dx. So here we are going to add dy, then here we are going to add dx. So we have y plus dy here equals to cos into, instead of x now, we have x plus dx. Now from there, you make dy the subject, you take y to the other side. So you have dy equals to cos x plus dx. This y is positive here. If you take it to the other side, it becomes negative y. Now, this is cos x plus dx. How can you expand this? You recall trigonometry. Recall double angle formula in trigonometry. If you have cos A plus B, this one is the same thing as cos A cos B, then minus sine A sine B. So you see we have cos A cos B minus sine A sine B. This is called double angle formula in trigonometry. So we recall this one because this one is similar to what we have here. This is A plus B, this is x plus dx. So x is in place of A and dx is in place of B. So this one can be expanded using this idea. So we have dy, this our dy, to be equals to, if we expand this one, instead of cos A cos B, then you have cos x cos dx. Cos x cos dx. Then minus, this is minus, put minus here, then sine A sine B. It means sine x sine dx. Sine x sine dx. You are done with this, you have minus y there. So this is minus, your y is the same thing as cos x. So now instead of y, you write cos x. Now from there, you can rearrange because you have cos x here, you have cos x here. You take this cos x to this place to match cos x and cos x. So we have dy to be equals to cos x cos dx. Then this negative cos x, you take it here. It will not change sign because it did not cross your equality here. So it is still negative. Then you have minus sine x sine dx. Minus sine x sine dx. So now you rearrange everything. Now after rearranging, here you have cos x, here you have cos x. So in this case, cos x is common. So you can factor out cos x. So you have dy equals to cos x into, here cos x already out, remain cos dx. Then minus, here is minus, cos x already out, you write 1 there. Because cos x times 1 is going to give you back your cos x. Then we have minus sine x sine dx. Now from there, you divide through by dx. You divide each term by dx because you are looking for what? You are looking for dy, you are looking for dy over dx. So already here, you have dy. So divide each term by dx. So you see here you have dy over dx to be equals to cos x into cos dx minus 1 still over what? Over dx, then minus sine x sine dx also over dx. So you see you have divided each term by dx. Now from there, you take limit as dx tends to 0. As dx tends to 0, you have your dy over dx to be equals to limit as dx goes to 0 of this one cos x into cos dx minus 1 over dx, then minus, right, minus there, then this one also you take limit as dx goes to 0 of sine x sine dx over dx. Now from there, this one cos dx here, you have over dx. So you have right now to factor out cos, because cos is constant here. Cos x is constant, you take it out. So you see you have dy over dx to be equals to, you take cos x out, the limit as dx goes to 0. Cos x is already out, now remain cos dx minus 1 over dx. Then minus this minus, or the same thing here, sine dx over dx. You see sine x is constant. You take it out, you have sine x out, the limit as dx goes to 0. Sine x is already out, remains sine dx over dx. So now, according to theory of limit, we all know that if you can recall, limit as x goes to 0 of cos x minus 1 over x is always 0. Also, if you have limit as x goes to 0 of sine x over x, this one is always 1. So this is another rule you need to recall here. Why do we say that? Because this one is similar to this. This is cos dx minus 1 over dx. This is cos x minus 1 over x. So this one and this one are similar. ds dx x x. This one dx over dx. This one is x over x. Sine sine. So this one also is similar to this. So the whole of this one is 1. The whole of this one is 0. So this implies our dy over dx is equals to, here we have cos x into this limit as dx goes to 0 of this is the same thing as this is going to give us 0 here. So we have our 0, then minus, right, you are minus, then you have sine x into limit of this as dx goes to 0 is the same thing as this, which is 1. So you write your 1 there. So your dy dx is finally cos x times 0 is 0. Then you have minus sine x times 1, which is minus sine x. So this is the derivative of cos x using first principle method. Thank you.